Buddy, it is 2 o'clock where I live. It is probably some other time where you live. Time for Unhindered by Coding. I'm Nick McVie. Going to spend the next 2 hours programming in not Rust, but actually Python in a turn of events. So I'm going to be working on Manim, the library, animation library. We'll get into details in a second, but you may well have seen people using this library online. And I'm hoping to use this to do animations of evolutionary computation concepts with the intent of making scripted videos for the YouTubes. Hello, Wagafa. Wonderful to see you. And thank you for sharing the updated version of your write-up. I have not gotten through it yet. Been in meetings all morning, but on the list of things to do, hopefully this afternoon after the stream, actually. So it looked really nifty. Thank you. It was nice that John gave you some feedback, so it seemed like there was a good conversation happening there. And the conversation in question happened on the Discord link here on the well, but I would love to look at it. And you know, you've been very helpful to me over the years. It'd be nice to pay back a little bit. So on my list of things to do. So I'm hoping to use Manim to make some scripted videos illustrating evolutionary computation. In fact, Michael Small Dev. Okay, this is going to be a slightly long story, but the university, the university has been, has had a contract with Google to provide Gmail and Google Drive and all the services for like 20 years or something now. And Google for much of this time was like, use all the disk space you want. We don't care. And at the time, early on, especially, I don't think we appreciated that they wanted that content for things like training their AIs, but they have in the last year or so gotten kind of grumpy about how much they're paying for storage on behalf of all of us. And so one of the things they've done, which I find very annoying the way this is played out, but they have eliminated a ton of old student accounts. So basically anybody who graduated or staff that have left, all of those accounts have been wiped out. And we had been led to believe that like alumni, as long as they remained active, use their accounts actively, then these things would be available. And they were for a very long time, and then all of a sudden policy changed. So a bunch of student alumni accounts disappeared, which is annoying on a variety of levels. But one of them is it's one of the main ways we have of contacting alums is we can use their old university, or we could use their old university email accounts, and we could stand some chance of actually reaching them. No, now all that's gone. Well, one of the other side effects of that is in Google Drive, there are, you can own a file but share it with other people. And if the owner of a file has their account discontinued, now that file will go away. And we got this email, probably March, maybe April, but I think March, saying at sometime in early June, we're going to start deleting files from people that aren't around anymore. And if you want to do something about it, you should go through and find these files and do something with them. And they gave us a query to make it a little easier, but it was so a lot of faculty spent a lot, and the day things start getting deleted is today. So a lot of faculty, myself included, spent a lot of time in the past week going through, in my case, many thousands of files that had been shared with me mostly by students. some by staff that have left, but mostly by students. Um, uh, I think not, because if the Pollinator project probably had a shared drive, and I think things in shared drives were safe. It was things outside of shared drives that were problematic. So if you, as a student, had turned something in by just sharing a Google Doc with me, then that's the kind of thing that would have disappeared. Or it turned out, um, if student reps had, so we elect, the students in a given major elect student representatives each year that serve as full voting members in faculty meetings of that major. And there are times that student reps would do things like take minutes for our meetings. And if a student rep took minutes before we had a shared drive, because shared drives didn't exist in the early days of our work with Google, then they owned those minutes, and those minutes were going to go away. So we had to like find those and make copies of them before they disappeared. Not that anybody probably really cares about minutes from 2012, but yeah, on principle, it seems like we ought to hold on to this stuff. So I spent way too much time this week doing a very generally not fun, just tedious, not unfun, but very tedious job of sifting through gazillions of files, and deciding that most of them I didn't care about. I wasn't going to save like random homeworks from 13 years ago. But one of the things that I found that made it all worthwhile, because I was able to save it, is Michael Small, the Michael Small dev in the chat, had, okay, we have to like go find these, because this is actually, I don't know if this is gonna, the audio, I don't have, I'm not sure this is gonna work very well, but I'm gonna try it anyway. Michael Small had the pleasure of being, oops, I'll do it over here, of being a student during COVID, and was in a class that I was teaching spring of 2020. And spring break of that semester, all the students got sent home and never came back. And all of us faculty had the 7 days or 8 days of spring break to figure out how to teach online. And I was teaching a class that Michael was in. And Michael, at the end of the semester, maybe it was something you were doing along the way, I don't really know, extracted weird choices that I made during Zoom lectures into these little files, and shared a folder of them with me, which I had forgotten about entirely, and came across in going through these files. And I was just like, oh, these are a joy. And I played these for my wife last night, and she just giggled herself silly. And so I'm going to have to, I'm actually, because they're very short. I mean, most of these are like under a second or a second or two. Hello, is it too long? I'm going to have to like put all these together just into a single MP3 and share them with my family, because I think our child in particular is going to just lose their mind. But I'll try playing one. I don't know how. I'd have to, if I knew OBS better, I could hook this up so that it was actually getting the system audio. This is actually going to be what's coming out of the speakers. I don't know if that's going to work or not. Oh, what? No, don't do that. Go away. Go away. Let's do this. I don't know. Could people hear that? I have no idea. Or so this is me making strange noises in class. And oops, oh no, I did it again. I don't want to do that. So yeah, that was us coping through COVID. in 2000. And Michael went through these Zoom recordings and extracted these noises. And thank you, Michael. That it gave me great joy then, and rediscovering it last night gave me great joy a second time. And I don't think I actually shared this with my family at the time. It was all so chaotic. And but I'm definitely gonna pull that out and share that with some people, because that was really fun to hear. So it going through all these old files, there was a lot of nostalgia. It's like, oh yeah, I'd forgotten about that student, or oh, I'd forgotten about that senior sim project. You know, there were all these like, oh, that was kind of cool. So it was sort of an interesting sort of walk down memory lane, if a slightly painful one. But it was fun, and finding that folder was absolutely the highlight. Absolutely the highlight. And thank you so much, because that just was like really a blast. So clearly, I need to do more sound effects in because I don't think I've done a lot of sound effects in the Twitch thing. But yeah, I think a lot of that happened, or at least some of that happens when I'm writing or doing something, and there isn't that happening here. So yeah, okay. But back to the plan. So Manim, what is Manim? Oh no, not you. Go away. So Manim. Is that going to be the right one? No, actually, this is not the community one. I want to go to the community one. Oh, actually, no. Let's start here. So, just for people who don't know, 3 brown, 1 blue is gapping his name. Sanderson, right? Grant? That's terrible. You'd think I would have done the homework and remembered this. Who is 3 brown, 1 blue? Grant Sanderson. Okay, so I got that right. Yay! Back to spring cleaning. Enjoy. Thanks for being here and giving me a chance to say thank you. That was a really wonderful thing. So enjoy. So Grant Sanderson has a YouTube channel called 3 Blue, 1 Brown. Yes, I always get that confused. Where he does very high quality math videos. And over the years, he has built this animation engine, which he calls Manim, that lets him do very nice animations of mathematical concepts. And there is a community edition. So there was a fork made some years back. And this is... So Grant doesn't pretend his is necessarily fully documented or ready for other people to use. He's happy to have you use it, but it's not what he's focusing on, which I totally get. But there were enough other people that were interested that they made this fork, which is more focused at sort of general usage. So that's actually what I'm focusing on today. And you can use it to make animations. We'll see that in a second. And so I was thinking it would be cool to potentially use this to create animations of evolutionary computation concepts. And so I tried it quick. Actually, I played with this a little bit several years ago and was like, oh, it works. But I didn't really do anything with it. But now, like, I have a specific thing I want to work on. So I'm hoping that I'll actually teach myself enough Manim to make some potentially useful videos. Manim's in Python, so we're writing Python today instead of Rust. I hope that doesn't cause too much mental anguish for some. But we'll live. And yeah, we'll walk through sort of making Manim happen, and And I've got a little animation started that is 90% what I want, but not entirely what I want. And I actually don't really know what is wrong with it, which is confusing and a little weird. So we'll have to deal with that and maybe fix it. So let's start with just setting things up. So this is their local installation. They also support doing this in Jupyter Notebooks, which I have not actually tried. That would be an interesting thing to experiment with, but I have not played with that. One thing that's interesting that I think has changed since I was here a year or two ago is they've now moved to recommending UV as their project management tool. And I really like UV. I had found that independently in some other stuff that I was doing. UV is actually written in Rust, so there is a Rust connection. And I have found over the years building other people's Python projects to be inordinately tedious and error prone. I found it very difficult to get at various points all the versions and the packages and the stuff to line up. It's been one of the nice things about Cargo is like you could be like, Cargo run, and it does, and you don't have to like think about it, and that's what I want, a project management system. And my experience of Python has not been that. So using Conda and pip and blah, 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 I've had just all kinds of issues. So I have been a big fan of UV when I found it and have used it. I think it's been like a really nice tool. And we used it in the evolutionary computation class this past semester when we did Deep, which is a Python evolutionary computation system. I showed the students how to use UV to install and run Deep, and it worked fine for everybody. Nobody had any issues. This is not my experience typically of doing these things, so like UV a lot. So they talk about installing UV. I already have UV installed. You can then install Python within UV, so UV Python install, and you can, with various flags and things, you can tell it to install a particular version of Python for your universe, blah, blah, blah. By default, it just installs the most recent one. So I have that. I've done this, and that's Python 3.13 or something. I don't remember. Manim also depends optionally on LaTeX. Now, it wasn't clear to me if I cared. I don't know for sure that we're going to need fancy LaTeX-y stuff, but we might. So I went ahead and, well, actually, I didn't do anything at first because I had LaTeX installed, but it turns out I didn't have the necessary bits. In particular, the LaTeX that I had installed didn't have DVI SVGM. And that's something that Manim uses to convert the LaTeX output, which is DVI, device independent format or something, into SVG, which is sort of a more truly modern device independent and scalable format. And I did not have a DVI SVGM in my LaTeX install, and I couldn't figure out how to get it. I think I was using TechLive, brew install TechLive, and from there I couldn't find a way to get DVI SVG installed properly. So after some searching and futzing, I actually switched over to using basictex instead of TechLive, and basictex made it then quite straightforward to install DVI SVGM. It didn't come with it, but it was easy to install it. So I did that. So now I've got a LaTeX installation that works. And then we get to actually doing stuff. So let's actually start doing stuff. and see how all this plays out. So this assumes you've got Python installed and that you've got the right LaTeX installed, and then UV init EC animations. So this creates a directory, in this case called EC animations, and initializes it as a Python project. So bloop, EC animations, and yeah, so we have, it gave us this Py project file, a simple main that just has a hello world in it, and a basic README that probably doesn't say anything. I didn't actually look at it. Yeah, it's empty. And then the Py project has the name of the folder, the project, your version number, your description, where your README is, what version of Python it depends on, and any dependencies that you have from there. So pretty standard project management tool. And now we are going to need to add Manim. So this actually, UV is very nice here. We can just say UV add Manim, and it will add the relevant dependencies. So Manim obviously depends on a bunch of things, 36 different packages. So an audio thing, Manim itself, NumPy, blah, blah, SciPy. So a lot of things got pulled in as dependencies. And now I think if we look at Py project, we will see that there is now a dependency on Manim, at least version 0.19. So that got added there. So this is similar to a cargo.toml setup. And then it also created a UV lock, which, has a lot of dependency stuff, blah, 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 which we don't care about. Okay, so there we are. And now at this point, we can actually run a health check. So they give us a Manim check health. Now, if you're using UV and you want to run a Python program, if you say UV run instead of Python, like normal, if you just were like running a Python program on the command line, you would typically say Python blah.py. In UV, you sort of run things through UV, and then that ensures that it's using the right environment, the right version of Python, the right dependencies. And it allows you to have multiple projects that can have independent setups. So we can do check health. And if I remember correctly, this takes a second. And there's some weird warnings, a spate of weird regex warnings that I assume some part of Manim is using some Python regex thing in a way that is considered not good anymore. So yeah, we get this set of things. So these invalid escape sequences, I don't know, somebody should just fix those. It tells us where a Python executable is, and then it checks to make sure we've got all these things. And this last one was where I was getting in trouble when I was trying to use the version of LaTeX that I already had installed. I was passing the first three, but I was not passing the DVI SVGM check. And like I said, I couldn't get it installed gracefully with TechLive, so I switched over to basictex, and it seemed to be all happy. So, no problems detected. Your installation seems healthy. Would you like to render and preview a test scene? Let's say yes, just to see what happens. And so when it runs, it creates these movie files, and then when it finishes, you get your movie. And that seemed to work. Yep, so there we are. So we have a working installation of Manim that is able to build a thing. So that's thrilling. Now we finally get to the actual programming part of the problem. So let me show you the, let's see, code dot, boop, and boop, and yes, I trust myself. So this is a Manim file that actually does something, and we'll look at what it does. Yeah, the change from 2 to 3, I think, caused a lot of people to feel a lot of stress. And the fact that they dragged it out as long as they did. I mean, they're like, everybody should use 3, but it's okay if you want to use 2, but really you should use 3. But we're not going to actually push you to use 3. And I was teaching some Python stuff at the time, and man, it was a nightmare because you would search for things online because that's what students, well, did. Now they probably ask an AI tool, but back then you would search for things online, and it was a real turkey shoot whether what you found was a Python 2 or a Python 3 solution or answer or whatever. And the students were just constantly confused about where they were in that space. It was very frustrating. I think it has gotten a lot better. But UV is fairly recent. Let's see, UV Python. So UV descends from something else. Do they say? There was something else before UV. And the people who were working on that other thing sort of kind of dropped it and built UV instead. And I don't remember what the other thing was called. It doesn't really matter. But it is, in my experience, very nice. It seems to work well. It's advertised as being very fast. I don't know or care. I'm not building anything big enough that this actually really has mattered for me. But this first line here is the thing that totally wins, right? It does all of this stuff. The virtual env stuff, pip, does all of it in one thing. It seems to do it in a way that works. And I have been like really happy with this. It has been made my Python usage much less annoying than it had been. So I'm a big fan. Go UV. So let's actually run this and we'll see what it does. And then we can talk about how we got here. So UV run, Manim, PQL. I don't actually know what those flags do. I should figure that out. And then you have the name of the file and the name of the scene. Whoa, that was not going to be 2-point crossover scene. Okay, fine. You'll show it to me, but you, whoa, out, no, poop. There we go. Blah, blah, blah. Oh, yeah, let's make this a little bigger and move you down out of the way some. And so we'll talk about sort of how we got here, but what I wanted to illustrate just as an example is 2-point crossover. So this is an animation that illustrates 2-point crossover in a linear fixed length evolutionary computation system. And so we have parent 1, we've got a set of genes or bits or whatever we want to think of them. I've deliberately not put values in the boxes because it's really just the existence of the boxes that matter. And parent 2, we've got a set of boxes, and we can discuss whether we think there should be values in these boxes. I don't know. And then child is initially, they're empty, they're blank. And the idea is that, you know, we bring blue ones down. Oops, I didn't mean to do that. That was interesting. We bring blue ones down in certain places, green ones from parent 2 and other places, and illustrate that that's what's going on. And this mostly gets us there. We get the 2 crossover points. So it indicates where the crossover points are. And now I would expect the goal would be that these squares would be blue, these would be green, and then these 4 here at the end would be blue again. And we get the nice animation, but the color disappeared. I've got the transform wrong or something. I'm not quite sure what I have wrong, and hopefully we'll figure something out about that today. But this is, a starting point that does seem to, get me maybe 90% of the way to where I wanted to be. Now, because I am a lazy human being, and I wasn't sure how easy or hard that was even going to be. Like, I really didn't have any, having not used Manim before, I didn't really have any sense of how much code was going to be necessary to get to where I wanted to be on this thing. I just totally wimped out and asked an AI to build me the first version just to get started. And as it is the case with AI tools, I got most of what I wanted, but not exactly what I wanted. And I tried asking it a couple of times, like, hey, I'm not getting the transform's not doing the right thing. And it gave me some other options, none of which were right, and most of which were way more complicated than this starting point. So I kind of rolled back to this, and we'll see where we go from there. So this is code that was created by Google Gemini. And at the moment, I haven't really touched it. I did fiddle with it a little bit to see if I could figure out where the transformation problem was happening. I didn't get very far, kind of unwound what I did, and we just have, so this is literally just what Google Gemini gave me, and we'll try to fix it from there. And so the first thing I want to do is actually just go through, make sure I understand what's happening, because like I said, I didn't write this, and I want to make sure I do know what I'm doing, because I want to learn how to do this so I can do more of it later. And I want to do some refactoring. Like, at the moment, there is this one construct function that is just really long. Like, it's 100 lines. And there is lots of duplication, and there are obvious places for refactoring. Like, they've got these big section comments that, like, okay, section 1, define the parameters. Section 2, create parent and child genome M objects. I don't know how they pronounce that, whether they pronounce that mobjects or M objects, but those are Manim objects. So it's a type or a concept. I'm not even sure it's a type, because we're in Python land, so types are a little weird. But it's certainly a concept that it must be a type, actually, because there are things you can do with mobjects that you can't do with other things. And so we're creating VGroups, so vectors of things, and that's how we're getting the squares. So we're getting a collection of squares, and then we're arranging those to be horizontal, moving to the right. We could presumably change this right to left, and they would go the other way, or up or down, and we would get vertical arrangements of the squares. But I wanted left to right, and so that seems entirely reasonable. But this is the same in all three places. The only difference is the color. P1 color is blue and P2 color is green, and child fill color initial is black. And then, I guess the strokes are different. So the parents have, I don't know why the parents have different stroke widths than the child would. That's very weird. So there are some minor differences, but I think, there's clearly a function screaming to exist here so that we don't repeat all this logic 3 times. And I think I did. I may have fixed. I don't remember if this code's got the fit. They had this logic wrong about the edge cases for the crossover points. It was nearly right, but it wasn't quite right. So we'll want to look at that. But there's like a ton of duplication in these blocks, and I want to do something about that. And there's a lot of duplication here, and it seems like maybe there's a way to deal with that. So there's a lot of duplication. So I'm going to start by just refactoring the thing that we have to clean it up. And then I think the issue is this transform from copy call. I don't think that that's set up quite right. And that's why I'm not getting the color in the child that I want. So I'm guessing that the fix is somewhere in this code, but let's refactor for a while. We'll get down to this, and then we'll see if we can make sense of it. So, and actually before I do any of that, I should probably commit. Wow, there's a lot of stuff here. What if we stage everything? What are these guys? Are we get status? Who all is? Oh, the media folder has all the generated media. I wonder if one should commit that. Kind of guessing the answer is no. Should one ignore the media folder in Manim? Actually, let's say get ignore. In Manim. Should one get ignore the media folder in Manim? That is probably, I want specifically Manim here, folks. That's awkward. What if we put Manim at the front instead of at the end? I think the answer is yes. But I don't really know. Okay, that one's empty. Really? And then I bet tech will be empty. Yeah, tech is... All right, let's go into media. That was my mistake. Oh, there is a little something there. And there is a little something there. But I think this is all generated stuff. So I think ignoring it would make sense. Yeah. Boop. Partial. Yeah, I think it's all generated stuff. So I think ignoring it is the right idea. So, let's add media to get ignore. Manim media folder. Media slash boom. Get, oops, backup one. Get status. Is there anything else here? I'm guessing the rest of this ought to be kept. And that did conveniently bring us from a bazillion files to 7, which is a huge improvement. So let's go ahead and add everything but my 2-point file. Can I just do, I'm not, there we go. Aha. Boom. Oh, oh, what? No, that's the one I didn't want to do. That was so weird. Stage changes? There we go. That's what I wanted. So that's everybody. Commit initial project setup. Boop. Then I want to add this. Add initial Google Gemini animation. Yeah, code for 2-point crossover. And actually, this isn't entirely correct, as it doesn't copy the colors from the parents to the child in the way that I would like. It's also just one big file or one big function, which I would like to refactor. Boop. Bop. Oops. Oh, okay. And voila. So we've committed, so now we can change things. And we'll have Git to back us up. Now I don't know, so this first section just defines a bunch of constants. And I don't know if best practice is to leave those there, move them out of the def construct, but leave them in the class. They sort of feel like class level things to me and not things in construct. But I don't honestly know what people's sort of practices are. I don't think, yeah, so I can extract a method, but that would just return all these, and that's really not helpful. And I'm a bit of a Python idiot as far as things like classes and larger level structures, like defining functions and having functions call functions. Totally know how to do that. But larger level project structure, and in particular the class stuff, never really used it much. So yeah, I don't really know exactly what our best plan there is. I don't know, for example, can I define these at the class level, and what happens if I do? If I bring all these over one, no, it doesn't see them. So just moving them out, floating in space, did not do the right thing. Is there like a let or something? I can't imagine that's what I want. Nah. Obviously, I don't know this part of Python very well. So let's go ahead, back up, and leave those guys in construct for now. And maybe if we care, we can explore how to move them out. And let's extract a function here, because boy, there really is clearly a function that needs to be extracted. This is just terrifying. So refactor, extract function, extract method actually is what I want. See real world examples from GitHub. I don't even know what that does. Not doing that right now. So this builds a I guess this builds an individual or builds a genome. Maybe we'll say build genome. Build genome. Yeah, and then genome length makes sense here. Now we're taking all of this as arguments. That's a lot of stuff. Do I need all of that to be taken as arguments? Perhaps I bet I do, because otherwise, like, square buff is, where is that? Right here, square buffer is just referring to this method variable. And since I pulled that out into its own function, that is now having to be passed in. Yeah, and I think Python was the first language that I ever ran into that required self. Oh, so if I move these things out, I could do self dot the name. That's what you're suggesting, I think. Uh-huh. So if I were to, for example, let's just take square buffer out for fun. And if I said that, then could I say self dot square buffer? Oh, look at you. Go with Zitsu. Thank you. Yeah. And then where's this method down here? Oh, I'm passing it in, but I could not pass it in. Oh, it's actually, is that telling me that it's not being used anywhere? Oh, it's not defined anymore. Sure. But if I said self dot square buffer, then it would still work. I bet. So let's actually confirm that. Oh, this is going to be a terrible idea. UV run, yeah, that thing. Boom. Doodly doo. Bloop. 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 Yeah, okay. So, doesn't look like we broke anything. That's a win. So now we can actually get rid of square buffer here and get rid of it down here and refer to self.square buffer there. Oh, that comment is now in the wrong place. Why don't we put you there? And now these, these are references. Yeah, so self dot square buffer and self dot square buffer. So how did those actually work before? Did they work? That seems a little weird. But I think we've made all the shouting go away. So if we run it again, bloop, and yep, there we go. Awesome. So that seems to work fine. Is there a refactor option for those variables? Not if I selected them as a group. I wonder if maybe as an individual. No refactoring available. What if I select the whole line? Extract method, but that's not helpful. I don't want a method. I just want to turn them into fields in the class. So it doesn't look like there is, which is annoying, but there we go. Okay, so let's think about the parameters here. Actually, we can go down here. So to build the genome, we need the length. That's how many boxes we're going to have. So this is using oh, there it is. Yeah, the square brackets here. This is using list comprehension. So we're saying build one of these for every blah in this range of values. And the underscore says, don't care what the number is. This would be the range 0, 1, 2, 3 up to 9 if genome length is 10. And this would be 0, then 1, then 2. And we're not actually using that in the square. We could, but we don't. And so they use the underscore here. And then we're saying we make a square, which has a given side length. So it's weird that like they cooked this in, but they didn't give it a parameter name. They came up with names for all kinds of things, and then they dropped this magic constant here. That's very strange. So I think we'll want to fix that. And the fill color is this, so that name's bad. Can we fix that? Refactor. No refactor. Oh, I'd probably just rename it, right? Boom. Yeah. Fill color. Boom. And parent gene stroke color is a bad name, so we really just want stroke color. And stroke width. And I don't even know. We probably don't want these things to be arguments, actually. And gene fill opacity. So we're saying fill it with this color, use this opacity. The stroke is the color around the square, and this is the width of that line. And then this says, so this gives us a VGroup of these squares. So it's some sort of Manim object that's a collection of things. And this says we're going to arrange them on the screen left to right with this buffer space between them. And if we increase or decrease that, that's going to increase or decrease the amount of space between the squares. So really what changes here is the fill color. Kind of everything else is conceptually going to be the same unless the stroke color's different and should be different in some way. If we go back to our animation. Okay, so they have, I think they have black as the stroke color. Let's go find out. The parent stroke color is black, and the child stroke color is initially white, with the fill color being black. Hello, Eustace. Wonderful to see you. We are doing Manim stuff and trying to refactor some code that Google Gemini created that mostly illustrates two-point crossover correctly, but the transform's wrong. And instead of getting blue and then green and then blue down here, we just get these outlined boxes. So I think the transform call is wrong. But first, I'm just refactoring the code because Gemini's code was one great big blob. And I want to sort of make sure I understand it, and going through refactoring is a way of sort of making sure that I get what's going on. And so, yeah, the parents have black as an outline and white inside, or and their color inside. The child has white on the outside. Um, Actually, if we made the child white on the inside initially and black on the outside, we could just have black as the stroke color everywhere. And although actually the white with the black center does sort of maybe better indicate that this is kind of empty and waiting to be filled. Do, do, do. I have not. I mean, there are a lot, and there are a lot of examples in the Manim repository, and it's a lot to look at. And so I started by just having, because I wanted to have a sense of like how big, complicated was this going to be. You have a dishwasher, ha ha! Well done. That is a good thing. Dishwashers are very useful. Um, um, I just didn't have a, having not really used this, I didn't really have a sense of how much work this was going to be. And so, hey, getting your dishwasher sorted out is important. Um, so I just was like, okay, Google Gemini, write me some code. I just wanted to see like how big this was going to be. Um, well, there's a lot of plumbing and stuff that you have to deal with, which is can be a nuisance. Um, and so I like Gemini, make this, and Gemini made it, and it's not that much. So I think it suggests to me that this is an entirely plausible thing to do, and it's just it isn't entirely correct, but we'll figure that out. Um, but it was, it was as a proof of concept. This is gonna work. It was actually quite useful, so I was happy. Um, oh my goodness grief! Um, Yikes! That doesn't sound like any fun at all. Um, you've been a busy person, doing busy things. So, well, I'm glad it worked. After all of that. So I think actually, let's go back here. I think if I, oh no, I wonder if we just make the stroke white on all of them, would that annoy me? Probably not, actually. What if we made the stroke white? If I just change this to white here, boop. Is that gonna irk me? Do. Oh, did that not work somehow? Or do I have to? Oh, there it is. Ooh, that isn't very nice actually. That light blue and the white don't interact very well. Um, uh, you did. It was a lot of work. Wow. Um, I'm glad it worked and that things are happy because that sounds like a mess. Um, so that just doesn't seem super. I don't really like that white. Oh, but it was kind of nice on the animation coming down. Well, well, well. After all that work, can't use the dishwasher. That's frustrating. Dads and their power cords. Um, well, certainly. So gene fill opacity. The opacity, does that ever change? No. So I think we could totally take the stroke width and the opacity out. Yeah, uh, almost faster to mail it to you. It's certainly a lot less work. Or just go buy a power cord in Munich. I mean, that must be feasible. Okay, yeah, that'll work. Um, so let's. I'm going to move these guys out and join them up there. Oops, I guess we'll do that up there. Ba-da-ba-ba-ba. And then let's start with self dot. And actually, I'm just going to go away. I'm going to just get rid of these two in my function call. And here we'll do self dot so the things still compile and run. Oh, stop it. Self dot. And is everybody down here needs it? No. But I removed, so I have length, color, and stroke color. Length, fill color, stroke color. Get rid of these two guys. And this is self dot. And this is self dot. And those probably are the wrong names. Yeah, so this should just be stroke width. Gene stroke width isn't bad. And gene fill opacity. Boom. And so these will be gene stroke width and self dot gene. Oh no, that's not the one I wanted to change. It's this one. Gene fill opacity. Oh, and help, I messed you up. Gene stroke width. There we go. B Python. Let's see. Well, yeah, but he didn't write his code in any way that was meant to be educational, right? The videos are educational, but the code, there's a lot of it. And I guess if I like fished through all of his videos and found a video that was this kind of work, that might be useful. But there's also the problem that his version of Manim and the community version of Manim are different. And his is largely underdocumented, and the community version is still underdocumented, but better. And I don't know B Python. I do not know what that is. B Python. Oh. Oh. Oh, Python. Python. Python with braces. Oh. Well, I don't actually mind the white space. I know that causes some people to go crazy, but the spaces thing doesn't cause me any great grief. So I'm willing to live with it. At the moment, like that's a fight I don't need to fight. I'm happy just sort of toddling along with the. Well, I learned Miranda, which is predecessor of Haskell, back in the 80s, and actually programmed in it a lot. And it uses white space like this, and I got used to it. It doesn't really bother me. I'm not convinced it's the way everything should be, but I don't mind it if that's what somebody has chosen to use. So I'll toddle along. Okay, so does this now work? Yep, okay. So that refactoring is happy, and we've reduced the number of arguments a fair bit. And so then it's a question of, do I continue to have the fill color as and the stroke color as both as arguments? And I guess maybe the answer is yes. I think we'll go ahead and leave the stroke color there. So this will be stroke color. And then that we'll just have the two colors, and that'll be okay. And I don't know that I like that name. Parent 1 color and parent 2 color. Probably first and second would be even better than 1 and 2, but this isn't that big a code base. Genome length probably really should be out at the class level and not passed in, because it's not something that we want to have change, since we're in a fixed length universe. Having that change from individual to individual is probably a bad idea. And then I want this to be, I don't want that to come in as an argument. I want that to be self.genome length. Oh, and that needs to be a self.genome length. Wada, wada, wada. Oh, and I need another self.genome length. Okay. Is everybody else? Nope, there's another one there. Boy, it really would have been nice to have a refactoring to pull that out, but life's a challenge. Do. And doodaloo, doodaloo, doop, ba-doop, ba-doop, and we're done. Good. Okay. And that fixes that. Yeah, it is. Well, and it's I think people don't always appreciate the advantage of things like a strict type system. They're like, oh, I want to be able to just like call whatever and it'll all be fine. And yeah, that's great as long as you're just trying to write like little scripts. But if you actually want to write real code, having the system be able to help you out is very nice. And if there's a real type system in play, then the system can give you a lot more help. So, okay. So now build genome takes just two arguments: the color of the box and the stroke color. Yeah, absolutely. So do I want that? Do I want these parent colors to be local or out here? It's a great question. That should have been up there. I'll leave them here for now. Oh, and actually, does anybody know? Oh, yeah, I think, well, it wildly includes JavaScript. Holy crap, that's just a mess. TypeScript makes it better, but sort of. I mean, it definitely has the feel of a Band-Aid put on top of a sort of fundamental problem. And, like things like Clojure also has, the Lisp family also have this issue, and teaching Racket to beginning students there are times when they really get themselves in trouble because there's no type system. Um, it there's some stuff we get to kind of avoid at the beginning of the class because we could just be like, hey, do stuff, and it'll mostly work. But in you reach a point where you're trying to do something a little more sophisticated, and then all of a sudden the lack of any kind of type feedback is a challenge. And yeah, I think C, but for different reasons. I mean, C's a real odd doc because it's so close to just like smushing memory around in a lot of ways, and the ability to happily cast wildly unrelated things into other wildly unrelated things is okay. So now I think we ought to be. Oh, does anybody know what this star asterisk does at the beginning of this list comprehension? I honestly don't know. It just occurred to me that I do not know. I mean, I understand all the rest of this syntax, but I don't know what that star does. Let's go ask the internet. Python star list comprehension. The asterisk operator also unpack. Is that going to tell me something useful? That's all stuff I know. The asterisk in list comprehensions. The asterisk operator can be used within list comprehensions for unpacking iterables. Where I don't see an asterisk anywhere. Let's see. Unpacking argument lists. The arguments are already in a list or tuple but need to be unpacked for a function call requiring separate positional arguments. The built-in range function expects separate start and stop, so they're not available separately. Oh, yeah. That makes sense now. Yes, thank you, Eustace. What they were saying there and what you just said sort of caused it to click. I bet VGroup takes these as separate arguments. And yeah. Yeah, so VGroup triangle, comma, square. So I think it would expect these to be squares, comma, square, comma, square, comma, square, but we have them in a list, and the asterisk tells Python to unpack that list and treat them as separate arguments. Excellent. Thank you. That, yeah. So not only am I learning Manim, I'm learning random bits of Python that I didn't know. I've never used Python to build anything very big. Only really used it in a couple of different introductory programming contexts and have never built anything of consequence with it. So, learning new stuff. Okay, so now we ought to be able to replace this mess with self.build genome parent to color parent fill. What is it? Parent. Come on, go away. Gene stroke color. Gene stroke color. That's a long thing. And then child genes. Comment you out. Should again. Be self.build genome child fill color initial and child stroke color initial. Boom. And oh, the opacity is different. So gene fill opacity is 0.8, but the child fill opacity is 1.0. Am I going to care? I don't know. Let's find out. Have I closed that? Yes, I have. Run. And yeah, so that looks like we didn't break things, so that's good. So that's a step in a direction. So let's get rid of all this commented out code. Actually, I think we'll get rid of these lines. And then this creates a group. Yeah, so this uses down, where the call, the VGroup here uses, the arrange uses right to make them go left to right. Here we use down to have them go top to bottom. So we're taking the three, and here we see VGroup taking the three things as separate arguments instead of taking them in a vector. So that's why we needed the asterisk operator to unpack the arguments before. That was cool. So that makes a group down with some space between them. And then we add that genomes group to our scene. So we're making a scene, so 2-point crossover scene inherits or extends, I think is the right language here, the scene type. And so when we add it, we're adding that to the scene. And then we make the labels. So we have a text item, and it's next to the parent 1 genes on the left at this distance. Parent 2 next to parent 2 genes on the left at this distance. Child label next to child genes on the left at that distance. We could probably do some refactoring there, but I think I'll not worry about that at the moment. And then we add those labels, and then we wait. And that gets us to, so actually, let me back up. That gets us to here. And that little wait is why there's a little bit of space here at the beginning, because it draws all of this and then it pauses for a little bit before it moves on to the next thing. So there's a little bit of animation before, or a little bit of space, time before, boop, that starts. Okay, so yay, we did that much. Go us. Now, in fact, we could probably now make all of this a function, a method. What? No refactoring available? Really? Is that really? Why would that not be legal? Weird. I can extract method there, but the self dot calls seem to mess it up. No, that's not true, because this is perfectly happy. So, blah, blah, blah. Refactor. Well, and, by all means, feel free. So there's a lot to explain. So making videos of all of the many millions of things that need to be explained. It would not be a trivial thing. So adding that caused it to not work anymore. But if I leave that out, I wonder why that is. What is special about that next line? Oh, now it's not letting. What? I swear you told me I could do that a second ago. Is somehow the comment at the top the problem? Nope. Refactor. Nope. Huh. We certainly could. I was just planning on plopping them on my Nick McPhee channel. And I think all my videos are CC. Pretty sure that all my videos are CC. I don't know. Not sure the details. Which flavor of CC, but well, good luck, Wagatha. Thank you for being here. And I will try to give you some feedback on your write up. Like I said, maybe later today. For me, it's already later today for you. So why in the world? That is so annoying. I have an extract method there. And I can extract a method there. And I can extract a method there. And I can extract a method there. And now I still can? And now I can't. So weird. So weird. Maybe? Yeah? How strange is that? And I bet if I put it there, it'll work. He says, not really knowing for sure, but kind of thinking. Yeah, it's happy with that. Can I include the first comment? No. That is so like you can't have a comment at the beginning or the end. That's very odd. Well, I'm going to do this and pull that out. Extract method. And what's that going to be called? Build genomes. Sure. Go with that. And then I will put this comment in the function that we just made. Build genomes. Boom, bop, boop, boop, bop. Yeah, I don't know. I mean, maybe, but that would be an annoying hack, given that it wasn't that hard for me to just move the comment. The sequencing's a little weird. And yeah, I think we want parent gene stroke color to come after the parent fill colors, not at the end. And I pasted it in the wrong place. And that's going to require moving that forward as well. Boop. Parent 1, parent 2, parent gene stroke color, child fill color, child stroke color. Okay. Actually, could these all be local variables to build genomes? Does this get used anywhere else? I think it doesn't. So I think, in fact, I could take these guys here and move them all down into build genomes and then lose these aha, that needs to be parent 1 color. No, that's parent gene stroke color. Oh, I lost the, where did I lose that? Oh, I just didn't copy that down. It was in a different place and I missed it. So it would be parent go here, boom. There we go. And opacity isn't getting used. I'm going to actually delete that for now. And in fact, so some type ascriptions. We could like here, problem is like these are presumably something in, yes, it's a Manim color. I mean, so I could say Manim color. Is that helping a lot? Oh, and that actually, oh, it's probably in the wrong place. That probably goes over here, actually, right? That probably is that. Did that actually help a lot? Ooh, yes, we could change enable type checking. Hopefully that won't blow things up. Let's go for standard. See what that does for us. So then the question is, does that really bias anything here? It doesn't hurt. It would look a little more like Rust and a little less like Python. Oh, you think we might get better autocomplete? That's possible, because then it would know. And so, like here, if we said this is of type Manim color, and this is of type Manim color, oops, space. And let's actually teach it that Manim's actually a word. And we should probably teach it that objects is a word, because that's going to come up a lot. So that could be a thing. I don't object. And actually, oh, this is a place where multiple cursors would have been a smart plan. Oh, too late now. Now I assume that this is returning. Oh, this is returning a VGroup. Oops. Okay. And that's also going to be a VGroup. And then text is returning probably just text, right? Yeah. So this would be of type text. Oh, and again, multiple cursors, but whatever. So does all that still work? Make sure I close that. Yep. Whoa, we blew up the world. Parent 1 color is not defined on line 14. Oh, that's because I moved these down here. Oh yeah, there's lots that isn't working. So all of these things go away. Oh, and this is the type checking stuff. It's now crabby because I don't have types for these things. So argument of type list any cannot be assigned to parameter location of type vector 3D. Okay, so now I've probably complicated the world by turning. Can you just fix that? Start is NP array instead of point. Oh, so numpy.array is what Gemini is suggesting. Your idea of vector 3D constructor may be a thing. No, I don't want to say that. Go away. Let's try your vector 3D thing. So what is, so vector 3D, grumpy, why grumpy, not defined. Nope. Doesn't like the third one. What is it? What is point? Point takes a location, which is a vector 3D. So why did that not work? And in this example, they have point location equals, and then they just have an array of 3 values. So it's basically the same as what we have here. What if we say let v, if not let, this is not vector 3. It's like vector 3D is hidden somewhere. So vector 3D is a type alias which is not a object. No, I think actually it's probably time to look this up because I'm just guessing stuff at the moment. Manim vector 3D. Yeah. Vector 3D. Do not confuse with vector 2, vector 3D. Let's go look there. Class vector 3D shape, a 3D dimensional vector. That's exciting and unhelpful. Weird. It's not clear what you would, how you would get around this type problem. Because this doesn't seem to have a constructor, at least not in this documentation. ND array? You think so? ND array. Yeah, I don't know that that's, oops, oh, hello. Like, I assume you meant like this. I'm not, oh, so you think maybe ND array might be a thing that we can construct? Let's go find out. It's weird that I can't say vector 3D here. It's like it's not exporting the type somehow. ND array. Nope. ND, yeah. I mean, unless there's an import issue, I'm not getting there. Do we? We don't even have NumPy imported. Yeah, we don't have NumPy imported. Oh, and this warning wasn't there before, so that must have gotten turned on in when we added the type checking. Oh, okay. I think I don't want to break things any more than I have to. Settings. Can I find Pylance? Because I think it was in Pylance, right? No, we're did I try np.array? No, I don't think I did. Let v equals np.array. Oh. So that did load. Can I do np.nd array? Oh, I can. Can I say 1, 2, 3? Oh, I don't want let. This is not Rust. No. Does ND array take an array? Probably. Or none of that. So I bet this isn't going to work. Or it does. What's V then? So maybe that would be the thing. np.nd array, boom, boom. Oh, look at that. That did a thing and made the red go away there. So if we do np.nd array around all of these guys, that might get us to the happy place. It's a little tedious, but there we are. Look at that. Look at that. Oh, I guess we need one here. And then we'll need one here. And then got to come down and do this group. Another reason why all this code duplication is annoying is that if we had refactored this first, I think we would have avoided a lot of this solving the same problem in 8 places business, but there we are. And here. Oops, I missed one there. And I missed a close here, I think. Or not. Do I have too many? 1, 2, 3. 1, 2, 3. Yes, I have too many here. I bet I'm missing one at the end here, maybe? No. Yes. Where have I? Oh, did I delete this? Oh, I did delete the square bracket. Well, that definitely is going to mess everything up. Thank you. Good catch. No, stop it. Oh, did I make the same mistake here? No. Here is open, 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 only 2 closes. That's right. Open, open, only 1 close. Boop, bop. And then we need the NP array and an extra close there. That was fun. So now everything compiles. Or not. NumPy float 64 cannot be interpreted as an integer on line 25. Who wants NumPy float 64? Who wants that to be an integer and why? Does point only take integers? Problem is the AI overload. Okay, let me. The AI overloads don't even see that this is a problem at the moment, so I have to tell them. Is it that the what does ND array want? Who knows? That's not helpful. Point Vector 3D. So vectors seem to be, so I wonder if the problem is that this 0 should be a float or not. Or I wonder, should everything be a float? Yeah, I could tell it in the chat. What if I put float, float, and float? Oh, these are floats. I think this is the problem, is that these CP line things have floating point components. Oh, the indexes probably have to still be integers, don't they? Because those are actually indices into a... Oh, but they're being used... Yeah, these are being used both as indices into arrays and as... No, that is not doing the right thing. Float is incompatible with protocol supports index. This is turning into a real pain in the butt. Okay, so let's... I don't know. It is not. Now, if we just say array, can we just go back to the way that it had been? We can. And... Oh. So what if we... Let's just drop that line. Does line 25 compile now? Yes. Got past line 25, and then it wasn't happy using line 26. So okay, so NP array is the better play. It looks like it's more flexible. Do 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 do. Da da da. Da 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 da. And one more, and then I think we're good. Probably Control F would have been smarter. And line 37. Okay, but we got down to line 37. So that, oh no, hang on, line 37. Did I just miss one? I did. I just missed one, and Control F would have been better on that front. And it builds. No, of course not. We're here to watch Nick flail in his editor. Okay. That was a lot. Okay, so what all have we done? I have lost track of what we've accomplished here. So what has been changed? So we moved some parameters out to here, and we basically pulled all of that out into build genomes and had to make a bunch of fiddly bits. And more fiddly bits. And then we added build genomes, which called build genomes plural, which called build genomes singular. Wow. Okay. So let's, because it's 10 till, extract genome building logic. This extracts the building of the 3 genomes into separate methods. We also turned on standard type checking in Pylance, which forced us to make a bunch of changes in how points are constructed. Into, yes, thank you, good catch. Oh yeah, sure. I mean, there isn't a repository yet, but actually probably after we're done today, or maybe I just push it now. I was gonna push this to GitHub, and it would just be a public thing. And then we'll see sort of where stuff goes. And obviously, if you wish to contribute to this repository, that is totally fine. It's not, there's nothing very fancy set up at the moment. It's just literally basically this file and the initial setup from initializing the project, but that's about it. There are no stage commits. Cancel. I want to stage you, and you're probably just adding the spelling, so yeah. Commit. Okay. So in 8 minutes, I don't think I want to launch into the next bit of refactoring. So I think maybe we cease and desist for the moment. Fix the color issue. Oh, you mean in the transform? Well, that's the thing. I don't know how to solve it, and I don't know that in 8 minutes that's going to happen. So actually, let me ask a question instead for tomorrow. So what do we think makes sense tomorrow if we're going to keep doing some EC stuff for the moment? Do we have more document? I'm pretty sure we have more. Yes, we do have more documentation stuff, because there are some gaps in the top level README that are just stubs at the moment. So I think probably finishing the READMEs is the thing to do, or at least, yeah. So I think that's reasonable. So we'll plan on doing that, and maybe between now and next Saturday, if I have a hot minute, I'll try to do some homework on the transforms. I had a quick look in the documentation. Let's see, where transformations. I found a bunch of stuff on transformations. How about if I search transform? Yeah, so there's a ton of transformations that are supported. And actually, this isn't. Yeah, this is the one. Well, this Gemini got me here, right? Because Gemini put transform from copy, which is the reversed transform. So typically transforming takes where's an example? Here we go. So yeah, transform takes a starting thing and an ending thing and possibly some other information, but it transforms this thing into that thing. So it takes you from a thing to a thing, And the idea of transform from copy is it lets you do a reverse transform. You can say you want to take the thing you have and transform it from some other object. But then they don't have any examples. They just sort of tell you this, and there's no information. And I don't understand why the color doesn't come with it. Because the animation is basically right except for the color. Right, so it animates from the top to the bottom, but it actually turns the thing that's in the top into the thing that's in the bottom. That's really the issue. We don't want it to, like, the color goes away. It starts out as blue and then fades to black as it drops. So it seems to be transforming this into that. So do we have to like change the color of the child before we do the transform? Or I'm not really sure what the right answer here is. Because I'd really like this to just kind of replace that. And that the animation would move, because I like the moving, but that it wouldn't change the color on the way down. Yeah, so that would be possibilities to change the child color before the transform, but then I'd be worried that the child color would appear right away. And you kind of want these boxes to come down and just stay blue and then be blue when they get down here. I'm sure this is doable. I'm just not sure how to do it, but we could. So where's our transform? Here's the transform in question. So we add this transform from copy that takes the parent 2 gene at position I to the child gene at position I. So we could say before that child genes I, dot is there going to be like a set fill set color? Set, I'm not sure which color we'd be setting here, but we could say set, sure. Let's just see what happens. Wah, wah, wah. Do. Okay, well, what did that actually transform? The green turned into yellow. Well, that's interesting. So if I had the right color here, maybe the color wouldn't have changed. Maybe that does solve the problem. So this is parent 2 color, which is actually a local variable down here, but it's green C. Let's change this to green C. Green C. La 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 la. And the blue comes down. Oh, yeah. That does seem to fix the problem. The spacing seems to be different in the bottom one. That's going to have to be dealt with. Not sure what's happening there, but that does seem to solve the problem. Yeah, the spacing's definitely off. We'll have to figure that out. So if we set this to be blue, and then do the same thing down here, then I think that does fix the color problem. Seems like kind of not a great way to fix the color problem, but it does fix the color problem. Bloop. Yeah, that worked. Spacing, like we said, is definitely broken, but that does solve that problem. Oh, you know what? I wonder if this, because it's just set color, I think it's doing the stroke color as well as the fill color, and it didn't seem to give us an option. Perhaps it doesn't know what type child gene's eye is, actually. It's a V group, and it probably doesn't know what's in the V group anymore. And so it doesn't know that it has a fill color or a stroke color. And so it just has this generic set color that probably set everything. And I think that's probably why it messed up the spacing. Is the instead of a black border, there's now the color is the border. So they have to figure out how to deal with that. But I kind of think it's probably the wrong transform or something. And that was my gut instinct. Is we've got the transform broken somehow, but I'm not sure what the fix is. Okay, it's after 4. I should wrap up. And is it different with transform versus... So I think if we... Okay, let's comment this out. I think I tried the other transforms and didn't get an obvious win. Oops. Yeah, so that didn't fix it. And then replacement transform. Now, I don't know if I tried that one. Boop-a-doo, 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 boop-a-doo. Da-da-dum-bum-bum-bum-bum-boo. Boo. So that was different in that the color showed up here right away. Whereas here, the color doesn't show up until the blocks move down. So, yeah, I don't think that... I think that transform from copy kind of feels like it's the right thing, maybe, but then the color is off. Yeah, I'm not sure. Yeah, so let's wrap this up. We can fix this next week. This can be next Saturday's task, and maybe I'll try to do some homework and think about how to do that. Yeah, don't electrocute yourself. That would be really bad. So tomorrow, whoops, not that exciting. Sunday, 8 June, 10 to noon, CDT, UTC -5. Continuing to work on the docs for Unhindered EC. Boom, ba, ba. And then Saturday, yeah, I bet it does. I I would not vote for that. So that'd be the 14th of June, 2 to 4 p.m. CDT, UTC -5. Continuing to play with Manim. So yeah, so next weekend should be well behaved, and I should be here for both streams. And so just to say this out loud, I'll go say this over on Discord too. But one of the things I did this week is did some planning. Like what projects do I want to work on, and how do I structure my time so that all of that works. And I had been thinking I might add some streams, and now I'm thinking I probably won't. I think reassigning streams, so having this stream maybe focus on other things like this Manim stuff for now, instead of doing Advent of Code or whatever, is the better plan. And because I've got a bunch of other projects that I want to have time to work on, and a 2-hour stream is probably 3.5 to 4 hours of work on my end, and adding more of those is not really feasible with all the other stuff I want to do. So we're going to just stick with the weekend streams for now, and the 2 streams, and we'll toddle along from there. So thank you all for your help. I really appreciate it. I think, some progress was made. I learned some things about Python and Manim, and we will figure out transforms if it kills us. So thank you all very much. We'll talk to you later. Goodbye.